40.5.
What?
That's what I got too.
I got 40.5.
No, I got 9.
That's because you did 81 times 1/2.
Yes.
Look at the little thing. Follow directions.
But it's like the little carrot, remember?
Yeah, the little carrot's right there for you. Don't screw it up.
I did the here.
No, you didn't. Come up and show me.
Hold on.
You said it was your power.
I got 9.
Okay.
9.
Oh yeah, I got 9 too.
Are we ready to show Braden his error of his
That's what I
ways?
did.
Okay, what did Braden do wrong?
Oh,
Santos?
it's not no half, it's the ABC thing right here.
What?
Yeah, it's ABC slash.
Okay, Sal, what did he do wrong? No, he's missing something that I said is very important up top.
The parentheses.
He's missing the parentheses. You gotta use the
So did
parentheses.
I. Wait, Miss Cameron, can I show you how I did it? Look. Use the little ABC thing. That's like the little, that's the fraction little thing.
I came out like that.
Yeah, same.
Oh, nice. Okay, you can do it that way.
He's 2.5. You don't gotta be.
Okay, that's also fine. 256 to the 1/4. Would you guys do that for me? It's not 256 times 1/4. It's 250. Okay.
Dude, stop. It's 4. It's 4.
Okay, without using your calculator, does anyone want to make a prediction? What do they think 36 to the 1/2
Oh,
is?
6.
Okay, what's going on here, Santos?
It's taking half of 36.
It's not taking half of 36. 36 divided by 2 is not 6, though. What is it?
Wait, really?
Aiden, what's it doing?
You're just finding the square root.
Oh, the 1/2 power is like the square root. So what happens when we raise it to a fraction exponent like that is we're basically figuring out like the reverse of the squared, right? Isn't 6 squared 36? So 36 to the 1/2 is just going backwards, okay? Like this one, 9 squared is 81. 81 to the 1/2 is just going backwards. So if I was a betting woman,
What?
a betting man is a phrase, but you guys are probably too young for that. If I was a betting man, if I was a betting woman, I would guess that 4 to the 4th is 256, is it?
I don't think we
Check it out. 4 to the 4th, what is that?
256.
256, because 256 to the 1/4 was 4. Those processes undo one another.
What is it called when it's to the 4th power? It's like you got squared, cubed.
No.
Just to the 4th. It's no fancy. If you want to invent one, go for it. Okay, without your calculator, try this one. What do you think 8 to the 1/3 is? 2, but you can check it out if you want to. What do you think 49 to the 1/2 is?
7.
You might not know this one off the top of your head, but
2.
it's 2. Okay, we're rolling around here.
And then 8, is that one 8?
That's an 8. Ooh, what about that
Is that
one?
5?
5.
And then 2.
Oh no! Now I had to change it up on you.
That's 4.
Why is that 4?
Because you put a parentheses and
Anyone else want to know why it's 4?
The reason why that is 4.
I'm going to do something. I'm going to cover up that 2 first. What's that?
Plus
2.
18.
The cubed root of 8. Well, 8 to the 1/3 is 2, but then I square it and it's 4. What? Okay, we'll talk about that in a second.
This seems easy.
All right. Now, what is this little card for?
Cheat sheet.
Full page stuff.
For your square
Okay.
roots to not use your calculator.
So,
What?
I just want to show you how this works so that you don't have to pull your calculator out all of the time. These are the perfect ones, meaning that they're whole numbers, okay? Like if I asked for the square root of 20, it doesn't have a perfect square root. So these are the ones that are perfect, like the square root of 25 is 5. Square root of 36 is 6. Okay, here's what the root is. If you go forwards, this is the power. So 2 squared is 4. 2 to the 3rd is?
9.
2 to the 3rd is?
27.
No, it's right here, dear. 2.
8.
8. 2 to, this is the 4th power. 2 to the 4th is? 16. 2 to the fifth is 32. Okay, so if we're having a fraction power, then they just go the other way. We call it a root. The sixth root of 64 is 2. So going backwards is when you do the roots. That makes sense. All right.
Okay.
So here's how we do a rational. Rational has the word ratio in there. Do you see that? What does ratio mean? Yeah, how are rates normally written?
Oh, isn't
As
there
what?
like one, not semicolon, but like a colon?
You can, or you can write them as a fraction. So the reason they're called rational is they're fractions, okay? So rational exponents, AKA, all right, AKA, you know what that means?
Also
Okay,
known
good.
as-
We're not that young.
Yeah, we're pretty old.
Also known as fraction exponents. Okay. So the way that the fraction exponent works is on the bottom, the denominator tells us what power you would multiply the answer by. Okay, so in other words, let's look at the denominator. The denominator's 3, right? And 2 to the third is 8. Okay, the denominator here is 2. 7 squared is 49, and so on. Okay. And let's put a little example here. Give me a nice perfect square that you know. How about 100? 100 to the 1/2 power means what? 10. The reason why, BC, do you know what that means?
Before Christ.
10 squared equals 100. So that's the answer, and that's why.
What is the next question?
What is B/C? Like actually in math terms. Hold on, why'd you write it?
Do you guys really not know?
Is it before
I
Christ
know.
or
British
because?
Columbia.
Is it because?
Well, which makes sense.
BC pizza? Like,
What makes sense here? This is this, BC, because 10 squared is 100. Yikes. All right.
Ugly percent.
So let's do some then. Let's see if we can do them. Here's the deal. No calculators now, but you can use this if you want.
come on, yo.
Okay, if you can't remember it, use your
Yo,
root
Bryce,
card.
get off your calculator.
What's 9 to the 1/2? Raise your hand if you think you know.
Oh.
Bryce.
No, Bryce with the dinner.
No, I don't.
Okay. Santos, what's 27 to the 1/3?
I don't know.
Okay, Tommy.
9,
Nope.
3.
I know what you did. You did 27 divided by 3. That's a common mistake. We want to know what number to the third gives us 27. Or, hold on, watch, this is how you use this. If it's a 1/3, go look in the perfect cubes and look for 27. The root is 3.
What?
No, where's 3?
Oh, I thought
Okay.
it was above.
Come right here.
Oh, okay, I get it now. I don't know.
So when you're doing your root card, these perfect sixths, think of the 1/6, okay? You'd use this column for 1/6, you'd use this column for 1/5, and so on. All right, 1/2. So I go to the 16. 16 to the 1/2 is 4.
Bro, what?
Oh, but what about 16 to the 1/4? We'll go.
That's 2.
16 to the 1/4 is 2. Why? Because 2 to the 4th is 16. That's why. What about 64 to the 1/3? So I go to my perfect cubes column.
Yeah,
4. And if you ever want to check if you're right, you could use your calculator for this. You would go 4 to the 3rd power, or 4 times 4 times 4, and you get 64. Okay. 81 to the 1/4. 3.
The next one's 10.
The next one is 10.
And then the next one's 10 as well.
Oh my god.
It is, because 10 to the third is 1,000. Okay.
What the? Can I use my calculator for this?
No. What about if we have a numerator and a denominator? Then here's what, it's actually pretty easy, guys. You can do it all with this, okay? This is where, I know, but I'm giving you this, Sal. I'm promising you this will be easy. So when we were doing what we did the last couple days, remember how we were saying a power to a power, you multiply them? So we're going to break this into the 1/3 and the second power. So now look at your root card. What's the third root of 64?
Do that.
4, and then I'm going to square it. What's 4 squared?
I don't know how to use this card. I'm confused.
Okay, I know, but Santos, if you just blurt things out all the time, that does not help. Just try to focus. Okay, I'll show you with the root card. So the very first thing on 10, would you rewrite this as 64 to the 1/2 power? Because that's what the fraction part is. And then raised to the third. That's what it means.
Wait, so you put 64 to the what power?
Okay, look at the bottom. Do you see it's a 2? That means it's 64 to the 1/2 to the third. The bottom is like, it's like 1/2 times 3 is 3/2. That's what I'm doing. Okay. All right, Santos, this is how you use the root card.
Okay.
This 64 to the 1/2, since the bottom is 2, that means it's a square root. So I go to the squares column and I look up 64, which is right there, and that is 8. Okay.
So 8.
Now, 8 to the third,
Yeah.
if I'm going forwards, then I go, the 8 is my root. So 8 to the third is 8
5.
to the cube, that's cubed, is 5/12.
Okay. I'm trying to get it now.
All right, break this one down for me. 27.
To the
What's on the bottom though?
to the 1/3.
Yeah, so we're gonna do 27 to the 1/3, and then after that we're gonna square it. Okay. Get the root card out. What is 27 to the 1/3?
3.
3.
And then
3 squared is 9. Do we need to keep? You want to keep doing this?
No.
We'll do a few more. The root card you can use on a test. Yeah, that's what I'm giving it to you.
Yeah.
Don't lose it. Okay.
I don't have extras.
81. Okay, what's the fraction? 81 to the what? 1/4. And then we're going to raise it to the 5th. So we go to the 4ths
We
column.
use the numerator as what we're.
The numerator is the one we raise it to at the end. You're right. Yeah. So the 1/4 of 81 is 3. So now we're at 3. So we got back to 3, and now 3 to the 5th is 243.
I agree.
It's kind of like you just doing it quickly, like 81 to that 1.25.
Are we gonna be
Okay.
able to use
5 over
So here's what I'm going to
4.25.
tell you. There are things like this that you will have on like a PSAT and SAT that you will not be allowed to use your calculator for. So you should know some basic ones. Like I would know the cubed root of 27. We're going to keep working with it, but you should know that. The cubed root of 8,
It's 27 1/3.
27 to the 1/3 is 3. Because 3 times 3 times 3 is 27.
I use my sheet on the.
You're going to sneak it in. All right, let's do this one.
Stop.
8 to the 2/3. How would I rewrite that one?
8 to the 1/3.
8 to the 1/3. Santos?
What?
8 to the 1/3.
Yeah, that's
And then
what I have.
squared. Okay, Santos only. What's 8 to the 1/3?
8 to the 1/3. That's 8 to perfect cubes, right?
Mm-hmm.
5 to 12. Right?
No, you just did 8 cubed. I want the 1/3, so if I want the 1/3, you look at the perfect cubes and find the 8.
Oh, 2.
2. The root, the 2, and then we're going to do 2 to the second, so 4.
8.
Can we do this one in our head?
What?
Yeah.
This is 4 to the 1/2, and then we're going to cube it. What's the square root of 4? 2.
What?
The square root of 4 is 2. 2 to the 3rd is 8.
That's what it says. 4.
Yeah.
4.
Okay, 25 to the 3/2. That's 25 to the 1/2, and then cubed. What's 25 to the 1/2? 5. 5 cubed is 125. 16 to the 3/2 is 16 to the 1/2 and then to the 3rd. You ready, Santos? What's 16 to the 1/2?
16 to the 1/2.
It's the same as the square root of 16.
Okay.
If you could think about what that
4.
4. And now 4 cubed.
Mm-hmm.
64.
Okay.
Trying to make it sound.
Now, I just want to quick show you this. We're not going to do this part till Monday. But remember how I've been saying that the 1/2 power is the same as what?
What the?
The square root, right?
I ain't doing that.
Okay. So what I've been saying is this. 9 to the 1/2 is the same as writing the square root of 9. So these exponents can also be written as roots. Okay. And so that's what we're going to work on Monday. There is a square root, you're probably familiar. Did you know that there was actually a cubed root and a 4th root and a 5th root?
No.
I'll just quick show you it. We're not going to assign it for homework, but like if I asked for 8 to the 1/3, that's 2, right? The cubed root, it looks like a square root symbol, but you put a little 3 right there, and that means the cubed root. So what we're going to talk about on Monday is, hey, how do you put it as going back and forth between those forms? Okay. All right, so